Hi guys, and welcome to another video in the HSC Chemistry video series for the topic production of materials. In this particular video, we're going to be continuing our discussion from one of the previous videos on ethanol's potential use as an alternate fuel source. Now, there are a couple of important things to consider. The first thing we did on the previous video was just really look at its potential just to participate in combustion reactions, and it more readily does or undergoes complete combustion just because it requires a lower oxygen environment. But if we're actually going to use it seriously, or if we're going to seriously consider it as an alternate fuel source, then we're going to need to consider a lot more things than simply whether or not you can combust it. So these are some of the important issues that we need to consider. First of all, the renewability of the resource, the requirement for engine modifications. I mentioned in the previous video that at the moment most engines in Australian cars are not capable of taking very high concentrations. The use of arable land, carbon dioxide neutrality, complete and incomplete combustion, which we kind of already looked at in the previous video, and also food prices, and that's going to be something that will kick in at the end. Now, there's a few slides in this particular video, so let's try and work through them as quickly as possible and just analyze each of these factors. Firstly, the simple sugars that ethanol is produced from are most commonly sugarcane crops. So we get our sugars or our glucose from the sugarcane that becomes fermented to produce our ethanol. These are fast-growing crops, so as a consequence of that, we can turn these over much more quickly, and therefore it is definitely a renewable resource, and that's one of its big advantages over the fossil fuels. But in giving it a bit of a tick for renewability, what about the carbon emissions? Well, the first thing we need to do is to consider our engine modifications, and as I mentioned in the previous video, 15% is about as good as it gets at the moment. So we need much greater modifications of our current engines in order for them to be able to use a petrol ethanol blend that is higher than 15% per volume. So we've got E10 being sold in Australia, and that is indicated as about 10% ethanol by volume. Although in other countries this is much higher. So Sweden, for example, E85, a lot of the countries that have pursued some of this, in Brazil, for example, maybe up to 100% ethanol, but they have targeted this approach for a long period of time, and so their cars are specifically designed to run solely on ethanol. This means that if we can modify the engines, we can actually potentially use ethanol in much higher quantities than we are currently. Arable land is important because if you're going to grow the crops that you're going to use through fermentation to produce your ethanol, then you need to devote land to that. Now, sometimes that's going to be in competition with other crops and or livestock that you want to also run on that land. In addition to that comes the other problems associated with land clearance and any form of agriculture, which is those problems of soil erosion, deforestation if we've got to clear the land, the addition of fertilizer if the soil is poor, runoff, and also salinity. So each of these is a specific issue associated with land clearance and also the types of crops that we grow on the land. That means that we probably can't give it the full tick for as far as land is concerned, because there's some potential damage that could result as a consequence of devoting land specifically for growing crops that will eventually become ethanol for fuel. What about the carbon dioxide neutrality? Now, we saw in the combustion of ethanol that the amount of ethanol that was released was much less than for octane. So for ethanol, we have much less than for octane. But does this indicate carbon dioxide neutrality, or is the fact that the carbon dioxide that's released in the combustion of ethanol going to be reabsorbed by plants and through the process of photosynthesis produced back into glucose again? So we know carbon cycle, we know how each of these things will cycle around. The biofuels, which are ones that have been derived from plant materials, we have a nice little cycle going around and around here. So you would expect, if there's no net gain or loss, that we would have something that was relatively carbon neutral. However, there are other factors to consider, and that's part of the problem when we are considering something like carbon neutrality or carbon dioxide neutrality. And that's because, first of all, even when we carry out the process of fermentation, we only get about 15% ethanol. Anything that's much higher will just not allow the yeast to grow. So therefore, we have to go through the process of distillation in order to increase the concentration of the ethanol, and that requires energy. We need to cultivate and fertilize our crops. You can see pesticides being sprayed onto crops. We will use particular types of machinery in order to get the fertilizers in or to transport them there, and also to cut the crops down, process them, and so forth. There's a lot of transportation that's going to be involved from the side of the land, so wherever we are growing these crops into the factories or wherever that may be, that we're trying to then go from the crop itself through the fermentation process, through to the distillation and the final ethanol product for our fuel source. And what that means is that despite the fact that carbon dioxide being produced is going to be reabsorbed by the plants, and so you're going to have a nice little cycle, when we start adding some of these other processes that also require energy, that are also going to be drawing on the burning of something, whether it's more ethanol or fossil fuels or petrol, in order for these things to occur, we're going to have something that is not overall going to be carbon neutral. So that can unfortunately get a tick, but it is, as I mentioned previously, releasing less carbon dioxide per mole of fuel than the octane does. Now, one of the other problems when you start devoting land to the growing of crops that are going to ultimately be used for fuel production is that you can't grow them for food. So historically, in 2007, a third of the corn harvested was used in the production of ethanol. Now, this decreased the amount of corn available, and with decreasing supply, so as the supply goes down, so the price goes up. And if the demand remains the same, and often the demand is also increasing, so demand is also increasing, so each of these two factors together have a significant impact on food prices. 2008, as a consequence of that, the World Bank reported a 75% rise in the price of food linked to the production of biofuels such as ethanol. So unfortunately, this one also gets a big cross. So some of the positives about ethanol as an alternative fuel source is it's renewable, it has lower greenhouse gas emissions potentially. We can use it for up to about 10 to 15% in engines without major modifications, and also there's less chance of carbon or carbon monoxide being produced in incomplete combustion. However, arable land is needed. Often food prices are adversely affected, they go up, and carbon dioxide neutrality is a good idea in theory, but in practice at this point it's not feasible. So make sure you're able to argue both sides of this case, but you should still be able to come down on one side more strongly. Your evaluation, that's going to be pretty much up to you and how you structure your answer in order to support your position. But given the problems with food prices, we need to put a little bit more of our research in to really seriously consider the overall impact of ethanol being used as a substitute for petrol. However, it's potentially something that may happen in the future, and important to keep an eye on the developments as they continue as at present. Thanks for watching.